Ever wondered where all the aliens are? The cosmos, in all its infinite grandeur, twinkles with countless stars, each potentially a sun to its own planetary system. As we probe the depths of this vast expanse, the question of extraterrestrial life becomes not a matter of if, but of where and when. Consider the Drake equation, a probabilistic argument used to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way galaxy. It factors in variables such as the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life as we know it. Let's break it down. Our galaxy alone boasts hundreds of billions of stars. Recent discoveries suggest that most of these stars are orbited by planets, many of which lie in the habitable zone. This Goldilocks region, not too hot and not too cold, is just right for liquid water, a key ingredient for life as we understand it. Now, if only a fraction of these potentially habitable planets develop life, and a fraction of that life evolves into intelligent beings, the number of advanced civilizations in our galaxy alone could be in the thousands or even millions. But here's the catch. If our universe is so conducive to life, if the conditions are just right in so many places, then why, in the immortal words of physicist Enrico Fermi, is everybody? Why haven't we picked up alien radio signals or found extraterrestrial artifacts, or at least spotted some UFOs that can withstand a bit of scientific scrutiny? So, if the universe is teeming with life, why haven't we found any signs yet? This is the question that has puzzled scientists for decades, leading to one of the greatest paradoxes in the realm of astronomy. But don't fret. As we venture further into the cosmos, our understanding deepens, and with it, our chances of finally answering the question, where are all the aliens? Welcome to the Fermi Paradox. This is a conundrum that has puzzled astronomers, scientists, and curious minds alike for decades. The paradox, named after physicist Enrico Fermi, highlights a contradiction. Given the vast number of stars and planets in the universe, why haven't we had contact with extraterrestrial civilizations? Let's delve into this paradox a bit more. Imagine the universe as an endless ocean and the planets as countless grains of sand. In this ocean, Earth is just one grain among trillions. It seems almost unfathomable that ours is the only grain that has sprouted life. The probability of extraterrestrial life is high, yet the silence from the cosmos is deafening. Several solutions have been proposed to solve the Fermi paradox. One chilling possibility is that we might indeed be alone in this vast universe. The unique conditions on Earth that allowed life to flourish might be extraordinarily rare, making us the lone beacon of life in the cosmic dark. Another theory suggests that civilizations might tend to self-destruct. As societies become technologically advanced, they could potentially annihilate themselves through warfare or ecological disaster before they get a chance to make interstellar contact. Alternatively, it could be that we're just not listening properly. Our search for extraterrestrial intelligence is based on our own understanding of technology and communication. Alien civilizations might communicate through means that are beyond our current comprehension or detection capabilities. The Fermi paradox forces us to confront our place in the universe, and the potential loneliness of our position is both intriguing and somewhat unsettling. But even if we haven't made contact yet, that doesn't mean we're not trying. Enter the search for extraterrestrial intelligence, or SETI. This dedicated research program, brimming with some of the brightest minds in the field, has been scouring the cosmos for signs of otherworldly civilizations for decades. But what exactly are we looking for? The answer might seem simple, but it's anything but. Firstly, we're listening for signals. These could come in the form of radio waves, much like the ones we use for our own terrestrial communications. Why radio waves, you might wonder? Well, they have the ability to traverse huge distances across the universe without being significantly absorbed or scattered by the interstellar medium. This makes them an ideal candidate for interstellar communication. But it's not just radio waves we're keeping an ear out for. SETI is also on the lookout for laser light pulses. These high-energy flashes of light, if detected, could be indicative of an advanced extraterrestrial civilization trying to get our attention. Yet, the cosmos is a noisy place, and distinguishing possible signals from cosmic background noise is no easy task. There have been a few instances where we thought we might have caught a glimpse of something. Take the WOW signal, for example. This strong narrowband radio signal detected in the late 70s caused quite a stir. It appeared to come from the direction of the constellation Sagittarius and bore the expected hallmarks of extraterrestrial origin. Despite its promise, however, no subsequent signals were detected, and the WOW signal remains a tantalizing mystery to this day. It's also crucial to understand that the search for extraterrestrial signals is a game of patience. The universe is unimaginably vast, and even if there are civilizations out there trying to contact us, their signals might not have reached us yet. Or perhaps they have, but we're not technologically advanced enough to detect them. And while we've yet to find a definitive signal, our search techniques are constantly improving. With every passing year, our capabilities grow, and our understanding deepens. So, as we continue to gaze up at the night sky, we remain hopeful. The silence of the cosmos is not necessarily indicative of a lack of company. After all, absence of evidence is not evidence of absence. Let's turn our gaze closer to home, to our neighbor Mars. The Red Planet, as it's often called, has been the subject of our curiosity and exploration missions for decades. These missions are not just about getting a closer look at this celestial neighbor, but they have a more profound purpose. They are our search for signs of life beyond Earth, of understanding whether we are alone in the universe. The recent Mars rover missions have been particularly interesting. Take NASA's Perseverance rover, for instance. Its mission, among other things, is to find signs of past life on Mars. It's equipped with a suite of sophisticated instruments designed to probe the Martian soil and atmosphere for signs of ancient life. This is quite a thrilling prospect, isn't it? The idea that there might have been life on Mars in the past, and that we could find evidence of it even today. But why Mars, you may ask? Well, that brings us to the exciting part. One of the most compelling pieces of evidence that makes Mars a likely candidate for past life is the presence of water. Yes, you heard that right. Water, the elixir of life as we know it, exists on Mars. Mars rovers and orbiters have found evidence of ancient river valleys and lake beds. They have even detected signs of liquid water beneath the Martian surface. And where there's water, there's a possibility of life. However, this doesn't mean we're expecting to find Martian dinosaurs or little green men. Far from it. If life did exist on Mars, it was likely simple microbial life. These little green microbes, as we like to call them, could have thrived in the wet conditions that existed on early Mars. So, while we continue to search the vast expanses of the universe for signs of extraterrestrial intelligence, we are also looking right next door, digging into the Martian soil and analyzing its atmosphere, seeking traces of life that once might have been. Mars may not have little green men, but it might just have little green microbes. So, what does the future hold for our search for extraterrestrial life? Well, it's a journey that's about to get even more exciting. Our quest for alien life is not limited to Mars. In fact, we're casting our net wider into the depths of our own solar system. Take Jupiter's moon Europa, for example. This icy world harbors a vast ocean beneath its frozen surface, which could potentially host some form of life. NASA's upcoming Europa Clipper mission, set to launch in the late 20s, aims to investigate this possibility by studying the moon's ice and subsurface ocean. And let's not forget about Saturn's moon, Enceladus. This intriguing celestial body ejects plumes of water vapor from its south pole, suggesting the existence of a subsurface ocean. The future Cassini mission is set to explore these plumes, searching for signs of biological activity. Beyond our solar system, the search for extraterrestrial intelligence takes an even more ambitious turn. The Breakthrough Listen project, for instance, is the largest ever scientific research program aimed at finding evidence of civilizations beyond Earth. Using the most advanced observing instruments, it surveys the 1 million closest stars to Earth and scans the center of our galaxy and the entire galactic plane. Meanwhile, the highly anticipated launch of the James Webb Space Telescope, the successor to Hubble, is set to revolutionize our understanding of the universe. With its unprecedented resolution and sensitivity, it will peer into the atmospheres of distant exoplanets, searching for chemical signatures of life. In this ambitious endeavor, we're not just looking for little green men or flying saucers. We're seeking answers to some of the most profound questions. Are we alone in the universe? Is Earth unique in its ability to harbor life? The future of alien hunting is promising and filled with exciting possibilities. As our technology advances, so does our capacity to reach further into the cosmos, bringing us one step closer to answering these questions. So keep looking up at the stars, because one day we might just get an answer to our question, where are all the aliens?